Welcome to your podcast for part 2 of lesson 40. We're going to be looking at internal forces acting on systems again, but now we're going to be adding in friction. You can tell that there's friction in this problem, for example, because you see the value of mu given to you, which is the coefficient of friction, and it's equal to 0.2 in this problem. And so let's say you have a system like you see in the picture here. There's two blocks, one with a mass of 4 kilograms, one with a mass of 8 kilograms, and we have one external force being applied to the system that's shown, and it's a 36 Newton force being applied to block 1. Now, we know that that's going to cause the system to move to the right, which means that this frictional force is going to be acting in the opposite direction towards the left, and our first step is going to be to solve for what that frictional force is so that we can then find the net force acting on the system as a whole. Alright, so I know my frictional force acts opposite of motion, and so I know it's going to be acting to the left. And I can solve for that if I treat the system as a whole. When I treat it as a whole or a single object, I know that my total mass is going to be 12 kilograms, and so I can find the weight of the entire system by taking that 12 times g, which is going to give me an FW of 120 newtons. So I know that FW is going to act straight down, and I also know then that my normal force, which acts perpendicular to that contact surface, is going to be equal and opposite of that FW. So that's 120 newtons as well. Now going back to something we learned in the last set of lessons, I know then that I can solve for my frictional force since I have my value of mu, and I now know my normal force. So friction force is equal to mu, so 0.2 in this case, times 120 newtons, and that's going to give me a frictional force of 24 newtons. Okay, so we can add that to our diagram. Now that we know that frictional force and we know it's going in the opposite direction of that applied 36 Newton force, I can find my F net, which then ultimately is going to allow me to solve for the acceleration of the system. And so we know that that net force is going to cause this system to accelerate, and since the 36 Newton external force is larger than the friction, we know it's going to be moving to the right. So we take Fa minus that force of friction, or 36 newtons in this case minus 24 newtons, which is going to give us an F net of 12 newtons. Okay. And so I can plug my 12 newtons in here and divide that again by my total mass of the system, which is 12 kilograms. 12 divided by 12 is going to give me an acceleration on the system of 1 meter per second squared. Now that I have that acceleration of the entire system, I know that that's going to be equal to the acceleration on each of these two boxes when I look at them independently. Okay, so we've just solved for the acceleration on the system to be 1 meter per second squared, and I know that's going to be the acceleration on both box number 1 and box number 2. I can calculate the F net on each of my boxes by using F net equals m times a. And so for box number 1 that has a mass of 4 kilograms, that's going to be equal to 4 times 1, which we know is going to give us an F net of 4 newtons on box number 1. Okay? So I can figure out this internal force pair between box number 1 and box number 2 because I remember I have a 36 Newton force acting to the right on box number 1, and I know that box number 1 is then going to come in contact with box number 2, which is going to push back. Now, I need to end up with that overall F net of 4 on box 1, and so the only number that I can put in that blank for that to happen, 36 minus 4, is 32 newtons. Okay. Now remember, box number 2 puts a force on box number 1, but box number 1 also puts an equal and opposite force back on box number 2. So that's an internal force pair, okay, and we know that those are always equal and opposite to each other. So we can take that 32 newtons then and add that into our diagram as we just look at box number 2. Okay, so here's the 32 Newton force on box number 2. And remember, we solved for our frictional force, which is going to be acting to the left. And that frictional force was equal to 24 newtons. Our overall F net for box number 2, again, F net is mass times acceleration. So our acceleration was 1 meter per second squared times 8. We should end up with an F net on box number 2 of then 8 newtons. And if you look at the two forces that are acting on this, you see that 32 minus 24 does indeed give you an F net of 8 acting on box 2. So if we have a problem like this where you have friction acting on a system, the first thing that you want to do is to find that value of the frictional force acting on the system. And remember, you do that by taking mu times the normal force. Then find the net force acting on the system. Use that to find the acceleration of the system. And then from that point onward, it's exactly like the problems that we did in the first part of the podcast for lesson 40 with no friction.